do a quick review, but we'll tape our review too, just because I think that some people could use the review later today as well.
I think that's great.
So, we started last week, and we have a test hopefully on Thursday. Don't forget test Thursday. So this will be a perfect time to review. But we started last week, if anybody can remember, talking about functions. And we had things that were called functions. And this part's all review, so I wouldn't necessarily write it down, but pay really good attention. And functions were written with f of x notation, which was the same thing as y equals. So first of all, f of x, y equals, they went back and forth. They were exactly the same thing. Then we talked about something called the vertical line test. Vertical. And the vertical line test we could use anytime we had a graph of our data. And so if we had a graph maybe of a parabola like this, or if we had a graph of some sort of a line segment, or if we had the graph, let's try to squeeze one more in there, of a circle sitting up here, we could test each of those using the vertical line test to see if in fact they were a function. And they were a function as long as when I made a vertical line, or I traced it with my vertical pencil here, all the way across, that only touched the line in one place as it passed across my diagram. So would we say the first one was a function?
Yes.
Yes, we would. How about the second one? Would we say the second one is a function?
Yes.
Yes, we do. How about our circle? Can our circle be a function?
No.
Negatory, because any place we go, like here and here, we're touching the line up here as well as down here. So this is not a function. We also looked at some data that was in tables x and y. And we said for every x value, there can only be one y value. So if we have some x values like 1, 2, 3, and 4, each one of those can only be connected to one different y value, like 2, 4, 6, and 8. It doesn't matter as long as each one's connected to one value. So yes, this is a function. Same thing holds true if I have 1, 2, 3, and 4, and this is what always tricks people, and they're all connected to 2. This is still a function, because for each one of these x values, it's only got one line coming out of it. One line out of the 4, one line out of the 3, one line out of the 2, one line out of the 1. When it was not a function, was when there was more than one line coming out of my x value. So x was connected to 2 different y values. This was not a function. And we were all pretty good on that. So we started with the quadratic family. In our quadratic family, our first family that we looked at, was the family that we'd write y equals x squared. They were all our parabolas. And they were all graphed with the vertex here at the origin, and they increased when they were in this y equals x squared format, up and out indefinitely, or to infinity. Remind ourselves again, this is the x-axis and the y-axis, right? So we increase on and on and on in both directions forever. If we wanted to move those equations around, we wrote them y equals x minus h squared plus k. Where this was moving it in which 2 directions? Who knows what h moves it? Left and right. And we should know that, so hopefully you're just sleeping because we've been doing it forever now, right?
Yes.
And the k moves it up and down. So we could plug in some number here, and that would move it on our x-axis, and we could put in some number here, and that would move it vertically. And then we added our second family, and our second family was the square root family. And our square root equations started with the parent function y equals the square root of x, and they always started here at the origin and went up and out in the positive x direction, positive y direction forever, or infinitely. And we also could move those around. And the H still moved it left and right. And the K still moved it up and down. And there were no other changes to that. And then we said, well, what if we wanted to flip it over and make it go down here instead? If we wanted it to go down there instead, what did we have to put in front of our square root sign? A negative, right. So this would have been y equals negative the square root of x. Or we could flip it over our y-axis. If we wanted to flip it over our y-axis, it was y equals, good job, the square root of negative x. And if we were really feeling especially tricky today, we could even flip it down here. And when we flipped it down here, it would have been y equals negative the square root of negative x. So negative, negative. And we all did pretty good on that, so we added a new family. On Friday, this is the one Miss Boyer missed, we added the absolute value family. Y equals the absolute value of x. Which when we graphed that on our basic graph, it was a V and we liked that. So it went up and out in both directions. And it had its vertex here, still at the point 0, 0. So everything was starting from the origin, and we were pretty happy with that. And we could move that left and right by adding an H value inside of our absolute value signs. And we could move it up and down by adding a K value outside. So this was still left and right, and this was still up and down. And we could flip that over the x-axis by making it y equals negative the absolute value of x. And we talked about why we don't want to flip it over the y-axis, which was what? It just was the exact same thing right here. Just the same guy looking exactly the same. So he wasn't very helpful. So we have this beautiful absolute value function. Up here on the top corner, the first quadrant, we have the function for the square root. Way up at the top, we have the function of the parabolas. And we did really, really well with all of those. So then yesterday, being that we were so smart and moving along so well, we added one last new thing. Let's see if I can find any piece of paper, because we used all ours. And the last thing that we added were the circles. So, sliding that up a little bit. Yesterday then we talked about the circle family. And we've already established today that circles are not functions because they don't pass the vertical line test. However, there was a very specific equation for a circle, and it made its own family. So we had x squared plus y squared equals r squared, which was the graph for a circle with its center at the origin, and it went r units in each direction. So if it was 1 there, it went 1 up in each direction. If it was a 4 here, it'd go 4 in each direction. And we said, okay, well, and we can move that around. And this time, the H still goes with the X, but we're going to move the K to be inside the parentheses here with the Y. So this letter still moved it left and right, just like it always has. And the K still moved it up and down, just like it always did. But now it's inside the parentheses. And remember, when they're inside the parentheses, they get us a little confused, so we do the opposite. And these two letters represented what part of our circle? Who remembers?
The center.
The center. Good job. So those represent the center of our circle. And this represents the radius of our circle. And if you drew ugly circles like me, then we made sure that we labeled that center 0, 0 and our radius however long it was so that we knew that we were covered on that. And we said, yes, Panda?
When is it gonna ask on the test what the center is?
It is going to ask on the test what the center is.
Well, is it always gonna be,
The opposite of whatever's in the thing.
so it would be just H and K, wouldn't it be negative H and negative K?
It's going to be like this. Let's do one. If you had that one, the center of this circle is the opposite of this, so it's 2 and negative 4.
Oh.
So the center is 2, negative 4, and the radius is 4.
Okay.
Okay, so it's these numbers with the opposite of whatever sign is in
And the
front of them.
radius is just like when you
Square root it. Perfect. And Miss Boyer, we did one more thing with those yesterday, and we said, well, if we stretch out a circle in one direction or another, it was called a what? Ellipse. E-L-L-I-P-S-E. I think that's how we're gonna spell ellipse today. And ellipses were also not functions. They were just circles that are stretched out or shrunk.
You're just not
I'm not, and it's early in the morning. Circles that are stretched one way or another. And so the equation was exactly the same. X squared plus y squared equals r squared. Except that now, we switch this to a 1 all the time, because that makes our lives easier. And we put the h, that's not even an h value. We put a horizontal stretch here. And a vertical stretch here. So probably the easiest way to look at that is to give an example. So if we had like x over 4 squared plus y over 3 squared equals 1, we would just graph it by hand because remember that was a lot easier than our calculator. There was no h or k up here, so our center is still going to be at the point 0, 0. We're going to go 4 each direction on the x-axis because under the x's are 4. So we went out 1, 2, 3, 4, 1, 2, 3, 4. And then we're going to go up and down 3 in each of our vertical directions. And then we just connect those points to get our eyeball looking ellipse there. And they can connect a little better. If they moved it on us, they'd have given us something like x minus 2 over 4 and y plus 1 over 3. Then we'd have this exact same shape except it would move over 2 to the which direction? Right, and down 1. So if we took this center, that's the point we move, over 2 and down 1, we'd start there and go over 4, up 3, and then draw our circle. So we worked on those a little bit yesterday as well as some other graphs. Anybody still have any other questions? Amanda asked a good question about the center up here, about ellipses and circles before we go on to anything new.
Well,
Yeah.
is there any more review we're gonna do on the ellipse?
Of course.
Okay.
We will today. Other questions? Alright. Then we'll switch to new notes now.